we're going to continue exploring the C.A.S.T rule. First of all, let's look at some definitions here that we're going to need when talking about angles in the four quadrants. So we have a definition here about an angle in standard position. Okay, that's this over here. In the coordinate plane, if its vertex is located at the origin and one ray is on the positive x-axis. So what they're saying here is that, okay, well, if I have, say, a line, okay, my standard position is going to be over here. Okay, so that's what I mean by an angle in standard position. And the reference angle is what is made with the positive x-axis or the x-axis in general. And the terminal arm is, where I end. And I can end over here, I can end down here, I can end down here. Okay, so this goes obviously all the way around. Let's say I stopped over here. Okay, my reference angle is not going to be from 0 to here, but in here. Okay, so for example, if this were 120 degrees, then my reference angle is going to be 60 degrees. So this kind of terminology is important because in order to understand the C.A.S.T rule in its entirety, you'll notice something very interesting here that, suppose I, using this example over here, suppose I took my first reference angle to be 30 degrees. Okay, so I have a 30 here, I have a 150, 210, and 330. Let's take all those in one at a time in our diagram here. So let's say this were 30. Okay, so I got 30 degrees here. And I'm going to go around. Let me try that again. I want to get another reference angle of 30 degrees over here. Okay, that means this guy over here is also going to be 30 degrees. So in going from my positive x-axis all the way over to this terminal arm, that's 150 degrees. And if I do sine of 30, that's the same as sine of 150. And again, they're going to have the same sign as in, plus or minus, because according to the C.A.S.T rule, okay, all are positive here, and sine is positive in quadrant 2. Let's go a little bit further. I'm going to go from my initial arm, I'm going to go into Q2, and then I'm going to go into Q3, just 30 degrees after my my x-axis in the negative area, in the negative quadrant. And I'm going to be over here. That's also going to be 30 degrees, okay, relative to the x-axis, but the angle itself, okay, all the way around from here to here is, I'm going to do a little line here, 210 degrees. And if you go on your calculator and do sine of 210 degrees, and let me just pull that up quickly. I believe it is 0.5, 210. Yep. You'll end up with negative 0.5. And again, no surprise there, because you are in quadrant 3 where only tangent is positive. Sine and cosine are going to be negative. But look, if I put a negative in front of the sine 210, that'll make this positive. And essentially, sine of 30 is the same as sine of 150 is the same as negative sine of 210. Let's go even further. Again, I'm going to start with my, on the initial arm, my terminal arm is going to go into quadrant 1, 2, 3, and into 4, such that I am 30 degrees, okay, away from the x-axis, but my angle goes from 0 all the way around to 270 to here, and that'll give me to 300. Let me put that over here, 300 degrees. And if I want, sorry, not 300, 330 degrees. It's going to be only 30 degrees below the x-axis, so 330 degrees. And look, if I do sine of 330, let me try that again, sine 330, I end up with negative 0.5, and if I put a negative in front of it, I get a positive, or in other words, this is the same as negative sine 330, which you'll see is kind of what we had here at the beginning. And that's why it works. The same applies for cosine, the same applies for tangent. Okay, just obviously you have to use the C.A.S.T rule to determine, which quadrant it's negative or positive in. But this rule applies now for not just 30 degrees, a reference angle of 30 degrees, but any reference angle. If I wanted to, let me just erase all this. If I wanted to, I could have a reference angle. Say I had a reference angle of 15, right? From here to here, let's say that were 15 degrees. Well, if I wanted to find the value of, so that's 15.2, and that's going to be 175. Sine of 175 degrees is the same as sine of 15 degrees, which is the same as, negative sine of, what is that? 180 plus 15. Again, I'm going to be down here. 195, which is the same as the negative of sine 345. Again, it's going to come here. 15, okay, downwards. Subtracted from 360 is 345. All these values are going to be the same. Okay, again, plus or minus some sign in front of the sine function, that is. So this, together with kind of the C.A.S.T rule, gives you a really cool way to determine the value of various trig ratios in a way that is pretty cool.